In the grand narrative of civilization, some events don't just mark a page, they tear the book in half. A global nuclear war would do just that. It would divide time into a before and an after, not measured in decades or technologies, but in the survival of organized life as we know it. To understand why, we must first look not at the bombs themselves, but at what they ignite. When a thermonuclear warhead detonates over a major city, the devastation is immediate and merciless. A superheated sphere erupts with temperatures exceeding those on the surface of the sun, vaporizing concrete, steel, and flesh in an instant. The explosion doesn't stop with destruction. It starts something far more insidious: fire. When entire cities ignite, a particular kind of inferno takes hold, not a simple blaze, but a self-perpetuating system. The heat draws in oxygen from surrounding areas, feeding the flames like a living organism. The result is a firestorm, a vortex of destruction that pulls material, gases, and debris upward into the atmosphere. It's not merely a catastrophe on the ground. It's a vertical column of annihilation, injecting enormous amounts of soot into the sky. This soot doesn't behave like ordinary pollution. Under normal circumstances, particles from forest fires or industrial sources are trapped within the lower layers of the atmosphere, where rain eventually scrubs them clean. But in a firestorm triggered by nuclear war, smoke is driven so high that it pierces the boundary between the troposphere and the stratosphere, a region far above the weather. Once in the stratosphere, the soot drifts globally. It does not fall. It does not wash out. It lingers. The earth beneath begins to dim, not from ash falling like snow, but from the quiet, invisible hand of solar radiation being intercepted miles above the ground. A veil of carbon dust casts a planetary shadow. What unfolds isn't a dramatic blackout. It's something more haunting. Day by day, the sunlight weakens, the warmth retreats, and winter, artificial and unseasonal, begins. This is nuclear winter, not a metaphor, not a theory, but a scientific prediction born from decades of climate modeling and historic precedent. It is the aftermath of fire, not just the bomb, and its reach is global. At first, the world might appear eerily normal. Then, slowly, chillingly, the cracks begin to show. Crops fail to bloom. Storm systems lose their rhythm. Snow falls where it never should, and rain vanishes from lands that need it most. It is not the blast that dooms the world. It's the shadow that follows. Imagine the planet as a vast biological machine, delicately tuned to the rhythms of light and warmth. Every stalk of wheat, every ear of corn, every flowering rice paddy. Each is a cog turning in harmony with the seasons. Now picture that machine grinding to a halt. As the sun's energy is muted by layers of suspended soot, the Earth's surface cools by several degrees on average. That might sound modest, but agriculture is built on razor-thin margins. Even small temperature changes, just a few degrees, can shrink growing seasons or prevent them altogether. The sun doesn't disappear, but its diminished reach disrupts evaporation over oceans, which means clouds don't form as they used to. Rain stops showing up on schedule. Some regions flood, others part. The cycle of planting and harvesting shatters. What follows isn't a Hollywood dystopia with empty shelves and desperate mobs. It's quieter, more systemic. The food supply begins to erode, not all at once, but relentlessly. One season underperforms, then another and another. What little remains must stretch farther. Prices rise, hoarding begins, nations retreat inward. The regions most at risk are the ones that were, paradoxically, once the most productive. The mid-latitudes, those temperate swaths through the U.S. Midwest, Eastern Europe, Northern China, are responsible for feeding billions. Their climates have been ideal for industrial-scale agriculture, but these are precisely the zones most affected by a sudden cooling. A few years of consistent sub-zero temperatures could leave fields barren. Machinery rusts, seeds rot, the breadbaskets of the world turn into wastelands. Humanity, for all its ingenuity, is not prepared for this. Global food distribution is not a rugged system. It's a marvel of efficiency, one that relies on 1 million interlocking parts. Fertilizer from one country, tractors from another, fuel from yet another, and ports, roads, refineries, and digital systems to stitch it all together. After a nuclear exchange, this network breaks, not simply from the bombs, but from the chaos that follows. Countries that once exported grain in vast quantities may find themselves unable or unwilling to trade. Why sell food abroad when your own people are starving? Protectionism becomes policy. Borders close. Aid dwindles. The basic math becomes terrifyingly simple. There are only so many calories left in the world. Take the global harvest, divide by 8 billion mouths. If the answer is less than one person's needs per day, you start losing people. The UN currently estimates that the world keeps only about 2 to 3 months of grain reserves at any given time. If production collapsed, that buffer would vanish in weeks. Starvation wouldn't be a slow death. It would race through cities like a fire in a dry forest. But this isn't just about biology. Food is politics. Hunger shifts power. It changes governments. It topples regimes. In the vacuum left behind, the strongest do not always rebuild. Sometimes the most brutal do. And still, the bombs may have stopped falling, but the hunger has only just begun. When scientists model nuclear winter, they don't begin with mushroom clouds. They start with spreadsheets. Yield, location, season, wind direction, fuel load per city block. Every variable feeds into an equation designed to measure something almost immeasurable. How much of civilization survives after the fire? The most commonly studied scenarios come from the flashpoints of today. Not science fiction, but real tensions that simmer in our headlines. The first is South Asia. India and Pakistan have fought multiple wars, and both nations now possess dozens, potentially hundreds, of nuclear weapons. A regional exchange between them would be devastating on a human scale. Tens of millions dead in a matter of hours. But the global effect wouldn't end there. Even with smaller warheads, scientists estimate that a conflict involving just 100 detonations could ignite enough firestorms to push 5 to 6 million tons of black carbon into the stratosphere. The result? A drop in average global temperatures by about 1.5 degrees Celsius. This is what researchers call a nuclear autumn, a less severe but still agriculturally disruptive climate shift. Some crops would fail, rainfall patterns would stutter, famine would stalk the margins of fragile states. Estimates suggest that even this limited exchange could put 200 to 300 million people at risk of starvation. But regional war is not the upper limit. A full-scale exchange between the United States and Russia, or a three-way conflict involving China, raises the stakes to an almost incomprehensible level. Thousands of warheads, many with yields dozens of times higher than those used in Hiroshima and Nagasaki, could be launched within minutes. Cities would be incinerated, but forests, oil refineries, infrastructure, and everything flammable in their blast zones would contribute to immense, continent-spanning fires. Modeling a conflict involving around 4,400 weapons, a plausible number in a maximalist scenario, results in over 150 million tons of soot entering the stratosphere. That's enough to reduce global temperatures by 10 to 15 degrees across the mid-latitudes, turning farmland into tundra. The darkening of the sky would not be visible in the dramatic way popular media depicts, but the cold would be real. Crops would fail, and not just in a few regions, everywhere. Initial casualties from the war itself might number in the hundreds of millions. But the famine that follows could claim several billion. Conservative models place global deaths from starvation over 5 years at around 5 billion. Whole continents would become graveyards. Surviving populations might number in the hundreds of millions, a fragment of humanity scattered across a much colder Earth. The term civilization collapse is often used lightly in fiction. In this scenario, it would be literal. Financial systems, digital infrastructure, international governance, all would fall apart under the strain of starvation, migration, and internal chaos. Even if the war ends in days, its consequences would unfold over decades. And what of the survivors? In many countries, especially those at the heart of the conflict, few would be left, but not everywhere would be equally affected. In the aftermath of a global nuclear war, much of the northern hemisphere would be rendered unrecognizable, not by glowing craters or mutiny, but by the silence of failed harvests and collapsed systems. Yet in that silence, not all hope would be extinguished. The southern hemisphere, distanced by geography and spared many of the direct blasts, becomes the subject of intense speculation. Countries like Australia, New Zealand, Argentina, and Chile sit far from the likely centers of nuclear exchange. Their skies may darken too, but not as much. Their winters may lengthen, but they may not freeze entirely. These regions, with their vast pastoral lands and relatively sparse populations, stand a better chance of keeping the wheels of survival turning, if only just. The resilience of these outposts wouldn't lie in luck alone. Their relative isolation, agricultural diversity, and lower dependency on imported grain make them uniquely positioned to ride out the storm. Livestock, more resistant to climate fluctuations than crops, could provide critical calories. Root vegetables and hardy grains, less vulnerable to shorter growing seasons, could fill in the gaps.
We need to implement rationing immediately.
With strong
or the
internal
northern
planning,
districts won't
these
make it through
countries
winter.
might
Look at the
sustain a minimum
projections. It's
standard of
collapsing
survival.
faster than anticipated.
But survival is a moving target.
We've lost control.
Even in the best-case
entire system
scenarios,
is
the
failing.
global economy would be shattered. Imports would dry up. Fuel shortages would bite. Medical supplies would dwindle. Populations fleeing starvation or nuclear fallout might arrive by the thousands, creating crises at sea and along fortified borders. Under pressure, governments might fall or turn inward, prioritizing national survival over humanitarian ideals. One chilling possibility arises in strategic circles: resource wars. If a country in the northern hemisphere faces starvation and another across the ocean still has food,
Heave
the
to!
question becomes
Stop
not
your
if,
engines
but
now!
how they might try to take it. Military invasions, piracy, or proxy conflicts could define the post-nuclear world not as a peace, but as a scramble for the last habitable niches on Earth. Even the survivors would not escape unscarred. Political institutions would weaken. The scientific and industrial base would shrink. Generations might grow up knowing only scarcity. In the worst cases, nuclear knowledge would be lost. In others, it might persist, a buried legacy waiting to re-emerge, possibly without the caution that once restrained.
Bring it forward.
Could civilization rebuild?
All right, set it down slowly.
Perhaps. Humans are resilient, but the rebuilding would not be quick. It could take centuries to re-establish the complexity of systems that once sustained billions. Knowledge may be preserved in bunkers, archives, digital caches, but access to energy, clean water, and stable climates would remain uncertain for lifetimes. The deeper question lingers long after the bombs fall. If humanity crawls back from the brink, would we learn? Or would we repeat the same spiral, armed with fragments of the same technology, telling
Look at these
stories of the
graphs.
time the sky
The
dimmed
conflict is
and the
escalating
Earth stopped feeding
exponentially.
us?
We are running out
Nuclear
of time.
winter is not a myth. It is a well-studied, data-driven warning from climate scientists, historians, and policy analysts
This
alike.
structural support
It
won't
is not about
withstand the
fear.
initial blast wave.
It is about foresight.
Evacuate the sector
Because
immediately.
unlike the
It's
natural
too late for
cataclysms of the past, this one would be of our own design. And that means it's one we can still choose not to unleash.